planar graph is one where the edges rather, do not intersect. So I'm going to draw K4. Now K4 is the complete graph with 4 vertices, where from each vertex I can get directly to another vertex. Now this representation of K4 is not planar because we have this crossing here. However, I could make this into a planar graph like this. I can join up each one from here like this. It's got no crossing so far. I can join this one up to here and this one up to here. Now we don't have any vertices crossing over at all. I've just got to join here to here, and I can do that by making a loop all the way around. So this now becomes the planar representation of K4. So let's look at K5. Let's see if we can do K5 as a planar representation. So I need 5 vertices. We'll put them nice and spread out. And we'll try and join up some of these vertices. So from the first one, that's quite easy. I can join up all of these. And I don't have any crossing. I can join that to there. Now, if I want to join from here to here, I clearly cannot go across here. So I need to do a loop around like that. And from here to here, similarly, I don't want to cross over any. So I'm going to do a loop around here. Now, from this vertex, I can go down. But I obviously can't go from here to here without doing a cross. I can also do that. I can't go to here without doing a cross. So I'm almost there, but I can't do it. Now, K5 is not possible to do as a planar representation because we're missing this one. And we're going to prove that later when we find out Euler's rule and so 2 spin-off corollaries for Euler's rule. Let's look at some bipartite graphs with planars in them. So I'm going to do, let's have a look at the K2M. Now, by representing K2M with one vertex here and one vertex over here, so that's my the two that I'm not going to join up, and I can have these going down the middle, and I can have as many as I like. I can always represent a planar graph of K2M because none of these will intersect. And then all of these, in fact, I don't actually have to draw them all up. All of them joined up like this. And this is a representation of K2M. So K2 can always be written as a planar graph. What about K3? So let's have a look at the situation where we have K3. Let's do K33. Now this is a kind of classic problem. K33 is a classic problem. So I have 3 dots here. I want to join them up with 3 dots here. And obviously the first one, that's easy. And this one needs to join into here and into here and into here. Now that's actually not too bad. That one goes in there. And of course, we already know that we can do the K2. So you join in this one, can just come to here. Then this one can loop all the way around to here. So no crossing so far. This dot here links straight into here. I can also link this dot up to here. But in order to link here to here, I can't do it without crossing over somewhere. Okay, so K33 is not a planar graph. And we're going to look at 2 classic proofs in a couple of videos time of K33 and why K5 also can't be written as a planar graph. We're going to actually prove that they can't be done as a planar graph.